Hello, everybody. So we've got a few things to go over tonight. Loops weren't actually listed as something for the homework until module 3. And I forgot that one of the module 2 assignments had that in there. I noticed that last summer when I taught the class online with Ivy Online. It's like, that's odd. Probably should have at least mentioned loops, but everybody's seen loops before. So I guess that got left out of our basic syntax coverage last week. But we need to look at those. Then we'll look at some, quickly look at lists and generators. I guess we need to get into functions to look at generators. Functions are the other thing tonight. You'll have probably seen some of the basics on functions in previous classes. We're look at closures and generators, and then comprehensions. Those didn't show up in the previous class. I put them on the list. Refactoring can be useful. We haven't talked about refactoring much yet, and that's making your code look nice. A lot of people at first confuse it with debugging, but refactoring happens after you get the program working. Because sometimes as we build programs along the way, as you all have all seen by now, I'm sure, our code can kind of end up being a mess. If we spread it out over a couple of days, we might be inconsistent with our naming variables, right? We choose different names on Tuesday than we do on Wednesday. White space is all uneven, and lack of any commentary or documentation, things that make it nice and easy to follow the code. So refactoring is just cleaning up the code, and can often be an automated process. Been using mostly the Spider. Well, I at least mentioned that I was going to use mostly the Spider IDE, and I'll point at the refactoring button on that. Most of our decent IDEs have a button that will give a bunch of suggestions for refactoring. There's some other uses of it. Has to do with cleaning up the code. So one thing that where refactoring shows up a lot, as far as something we want the process to be automated for us in IDEs, is if we decide to change the name of a variable or change the name of an object. Let's say that, change the name of an object or a function, something that we import into another Python script and use there, which then might be imported into another Python script after that, and we end up with a long chain. And if we wanted to suddenly decide we wanted to change the name of it, we'd have to dig through every single text file and find every place that shows up and adjust the name. So it's nice when the IDE can refactor that for us, clean up the names. Then we might get started looking at Django stuff. There is a lot of setup to Django. It's always the same. We'll take our first look at it this evening. I pulled out the Mac to go over it for the first time. And there's a big tutorial on there that was put in the Ivy Online one, and that's the asynchronous online. There's no class, nobody to cover it. So it's just a big, huge tutorial. And personally, I thought it was a little bit too big. It jumps into some fairly advanced features. So that tutorial walks through where if your site messes up, it will automatically stir up another server and recreate your site in a different place with no intervention from a human. Features like that are great, but features like that at the introduction level make it a little more complicated than it needs to be. We don't need that when we're being introduced to something new, right? That's kind of overwhelming. There's a lot of that stuff. And then the tutorial that was chosen doesn't seem to have been put together for any low-level Python course. They take for granted that people know Python. So one thing that I definitely noticed last summer, it was an asynchronous online class, so I couldn't tell for certain if people were doing this. It looked like some people were just going over there and digging through and looking for instructions of that were clearly Python instructions and running those. But the thing is, most of those need customized, and the 10 pages of reading before you get to that instruction or what you need to know in order to customize that to your situation. So there were a lot of little mistakes, little errors happening along the way. But the tutorial is Django Girls tutorial, and it does not seem to be designed for people brand new to Python. It looks like it's designed for people that are expert level in Python. So they, I thought they skipped steps and made it and added a lot of things that were kind of complicated for an introduction level. So in class, we're going to see what we need. And there's a lot of setup. Like, I tried to make a quick video last summer because it was confusing so many people, that tutorial, because I'm pretty sure a lot of people were digging through and they were just skimming as quick as they could, you know, scrolling as quick as they could until they saw a line that was clearly Python code. Then they go type that in, or clearly something that goes in the terminal and they type that in. But they scrolled past 5 pages that explained what they needed to know in order to customize that instruction. So then it didn't work. There was a lot of that. So I tried to make a quick video, and it ended up being 30 minutes long. That was as quick as I could get the set up for Django. And describe it, because the description of it is what takes a while. There are certain files. We have to have files with certain names. We have to have lists and variables with certain names. We have to have, and there's certain things that we have to have because the framework already has methods and objects that are going to use things with that name. So we have to know what those are, and then separate out the stuff that we can name ourselves, normal naming conventions. And there's quite a bit of talking in the initial setup. So we'll probably do the first pass of that tonight, but we'll do it a couple times and see just the part that we need for, well, the word introduction isn't in this, but we're not at like a 400 level class, right? There's still you've only had a few programming classes at this point. Most of you probably have had 10 years of experience with Python, right? If you've done that, you're probably not paying much attention. You're going to pay much attention when I set up the Django stuff anyway. So there's different ways. We'll look at the part we need instead of that super advanced tutorial that was just overwhelming everybody last summer. Nice and thorough, because I'm teaching this online the second 8 weeks again. So instead of making a video in a rush when everybody's panicking because they waited till Sunday afternoon to start asking questions about the homework due on Sunday night, so they couldn't get to work by then, and I had to make a quick video, I'll want to refer them to when I taught the class the first 8 weeks. Be like, yeah, that's way overcomplicated. Look, here's the classroom where I have full freedom to teach it. I have full freedom on how to teach Django. Just and see that introduction stuff without being in the rush scenario like I was last summer. Probably look at it twice because there's a bunch to remember, but when they're not talking about it and you just know what it is, it goes through really, really quickly. Another thing that confused people is the tutorial online always use virtual environments. We talked about that last week. It's a good idea. You start with a blank slate on Python, but it's not necessary. That's never a absolute requirement. And then when I would do stuff without using a virtual environment, it seemed to confuse people that had just read through that tutorial. There was a lot of things about that tutorial that seemed to confuse students, but it's there. I didn't want to delete the link to it. So in all of those, are they labeled labs or case studies? I can't remember the label, whatever the label is for those things in the modules. I left the original part there, and you can just skip over that. We'll talk about all the reading stuff in class and see the parts that we need. And a couple things that I just think are easier. A couple of, we'll see it the way I do it. Like always in programming, there's more than one way to do it. Probably share the proper way in style sheets, but I forgot what the proper way to do style sheets in Django was until it showed up in class last summer, because it strikes me as way more complicated than it need to be, and we end up with redundancies because we have to make several versions of the same style sheet. And always just went with an easier way. Instead of putting it in the project, I would just go find like a free domain host and stick the style sheet somewhere else on the internet. And then any page that anything on the internet can go grab that style sheet. I thought that was much easier than the proper way to do that in Django, but that's for a couple weeks away. Yeah, I guess we can jump in and start talking about our the list or the big one, but we'll quickly go over loops. Loops probably should have been covered in the first pass of basic syntax, but I think I forgot because I thought it wasn't going to show up the week 3 homework. And
Hey Chris, I'm sorry. So are you saying we can basically maybe possibly fetch a global style sheet?
yes,
Okay.
you can always do that. Oh, you had 255 class, Dev. So
Pardon me?
so if you think back to your 255 class, remember when you were working in JS Node
Mhm.
and you just put a URL in like every script you wrote? You just referred to it. It's just like that. If it's on the internet, we can go get it.
Okay.
We can always do that. If you were making like a maybe you're a really big Purdue basketball fan, so you want to make a website dedicated to Purdue, a fan site for Purdue, you want to use the proper colors and stuff. You don't have to go set up your own style sheet. You can just refer to their style sheet and go to I assume it's purdue.edu and check where the style sheet for their website is, and then just refer to that and just point to that because it's on the internet and it's publicly available on the internet, so we can just refer to it. We'll see that later. Week 1 was just background stuff, and we'll probably throw the words "Hello World" on the screen on tonight's introduction. But first, it's just some pure Python stuff. So I'm going Spider. So there's another thing I wanted to talk about related to that. I guess I could do first. We looked at the manifest stuff, so I'll do this while Spider opens up because text editor is going to open a lot quicker. We looked at that requirements.txt file. Oh, what is this? No, don't check for updates. Cancel it. And it does always need to be called exactly that. So I get the zoom buttons out of the way. Let me go to some working location. I can folder delete. Yeah. And we always have to call that file requirements.txt. So that's the file in the manifest. And if we didn't import anything, then we don't have to, it's a blank file. We can't put anything in there. Give it a blank file, and if you put anything in there, it'll throw an error. So an automated process is going to be looking for this file explicitly, and it's expecting certain things to be in this file, such as the libraries that we might use. And they jumped a step ahead kind of for the, what's that doing stuff? Oh, they kind of jumped a step ahead in that Django girls tutorial. If anybody started reading that, since I wasn't exactly, or didn't explicitly state it in class last week, you can skip over all the reading assignments there. I just left them there if you want to look at that nice big thorough tutorial. But if you haven't had me in class before, I will teach more than I test you on. Kind of like how I signed you all up for that AWS machine learning course, right? If you're interested, that's there. I figure we might as well take advantage of it because otherwise it'll cost you $180. But right now, if I sign you up for it, it's free. So I signed you all up for it if you want to learn that. Save $180. The exam still going to cost, certification exam still going to cost money, but you can get through the training for it and learn about machine learning because that's a big deal in the modern world. But I usually teach more than I'll test you on. And that Django Girls tutorial is very, very thorough. They cover a lot of things. One of the things they do is they install from the manifest, because we're not creating Django. That's not our script. Our final project is just going to depend on Django. So that means Django is something that goes into the manifest. I'm going to skip that completely because that's what the tutorial says. But to do another example, so far in class, I'm on the Mac tonight, so I have to type Pip 3 and Python 3. But if you're on a Windows machine, you can leave off the 3. If you're on a Mac or Linux, hopefully you already knew that you needed to type that 3 there. Part of the kernel for Mac and Linux was written with Python 2.7. So that's still there. So if we just say Python or pip, we get all the way back to version 2.7 from like 15 years ago, and which is way, way out of date. Oh yeah, I can show you. On a Mac, if I just type Python, I get a warning message to not use that version of Python. Similar thing on Linux. I know Kali Linux updated so that you have to type Python 2 to get that. And if you just type Python, you get Python 3, but most of them are still that way. So I need like pip 3. And we installed a few things, right? We installed the emoji library, say install emoji, and then went out and got that emoji library. Well, that is what goes in this file. Whenever we do that, it's going to ask for some other stuff. So in a manifest, maybe we made a project that depends on that emoji library. And we'd say we want emoji greater than or equal to whatever the current version is. So if I go search for that, emoji Python, we can see the current version is 2.2.0. So presumably anything after that will work. And this is what the requirements.txt file gets when we say it, when we have something to put there. Like, I guess right now I kind of have to pretend that I made a script that uses emoji. And we need to make sure at least version 2.2.0 is installed on whatever machine we want to run that script on. So we put that in here.
Okay, so since you went in and downloaded the emoji earlier, by you going and adding that requirement into the requirements text, then it'll read it and say, okay, use this for this script.
So the requirements doesn't say to use that. That's the import statement is what's saying to use that. But if we imported the emoji library, our script would just crash without it, right? Mm-hmm. The requirements is saying install this library. Do not run this if it's not installed. Okay. We'll see it in an example here. Let me grab these numbers. So TQDM, where's the Pi people thing? There it is. So on TQDM, we were in version 2.2.3 when we did that. So maybe we use that and did some meters. So like greater than or equal to 2.2.3. What else have we installed? Oh, we did Pi Auto GUI, didn't we? What version of that did we use? I would check this site to see what the version is, 0.9.53. Seems like with 53 patches, they might have gone up to version 1 by now, but everybody names things a little bit different, right? So Pi Auto GUI greater than or equal to 0.9.53. So there's all the libraries. Whoops, I'm on a Mac. Command S to save it. There's all the libraries we've imported. So maybe we made a script that would do this and we want to install it. So if somebody wants to run our script, they're not going to sit there and type all of those libraries, right? They're going to do pip install and We haven't got to how to publish it yet, so they'd have to do git plus https:// github.com/ I don't know if it's, I'll just put in mine. Right, y'all know what the GitHub address. Where we at? SDEV 220-spring 2023.git. That's the only one we
Do
wrote.
you have to put pip3 right there since you're working on the Mac?
Yes, I would. I wasn't gonna actually run this command because there's
Okay.
not a
Well, that's what
requirement.
I would write for Windows. That's what I would put.
But they're gonna run this command until we publish it, and then probably people and all those other repositories know about it. But then they'll just put pip install in whatever name. They're not gonna do all that other stuff. And pip will automatically look at the requirements.txt and install all of this stuff. It'll go through and look and see what's there, right? Remember when we install stuff, we see a whole bunch of different things happening. And we can install right from this. This is another one that confused people last summer is our final projects are going to depend on Django. We're not making Django. Django's something that we installed ahead of time to make our project. So it goes over in the manifest and we can install right from it. So if we do pip, well, we have to go to the right directory. So if I go into the documents, delete folder. So there's that file I just created. And when we say pip install something, it's going to look for that file there in that spot. And then in the background, it runs pip install. Make sure you push -r requirements.txt. And -r is like normal, the recursive argument or parameter. It's a parameter, but it's Boolean. So we just type the parameter name. We don't have to actually say true or false. Recursive, like if we have a folder, recursive means dig through all the subfolders and files in there. In this case, recursive means go through every line in the file. We don't want to just install the first one on there. So always remember the recursive call there. It works if there's only one line as well. And then we can install everything in that file. This is the command that runs in the background. And that tutorial, if anybody looked ahead, does that. Something didn't work. Normally an emoji, right major. Oh, I don't know why there's an S there. That S was problematic. Let me try that again. But it did install the first two, which is probably good. So the requirements already met on those. And then on that other one, well, PyAuto GUI depends on stuff. So it had a requirements.txt file. So pip needs to run that and go through and install all that stuff. So the same thing that happens when we install it, but it looks odd doing it from that, doing it from the manifest. And when it shows up in the tutorial, that might have been the first time you actually saw it done that way. So I wanted to cover that in class. And again, this video, the people in the spring, when I teach that the second 8 weeks in the spring, I'm going to point them towards this video because that tutorial by yourself late at night is a little overwhelming. At least it was for the first group to take the SDEV 220 class.
Can you send the link to that 30-minute tutorial that you made last summer in the announcements? I appreciate it.
We're going to do it different ways.
Okay.
Yeah. Then eventually it gets to the end of that. So we can, that's the command that runs in the background whenever we install stuff. So we can manually type that in. That way it's not so confusing when you see it in the tutorial. And any libraries that our stuff depends on, that's what really happens. That's what the manifest is for. So make sure that it has the right name and you only type the exact right things. And you notice that it just completely crashed when I accidentally pushed the S key. So we can't have any extra symbols or anything. Notice I did not put any white space. Don't put spaces in there. I guess I should have mentioned that explicitly. It's Python. White space matters.
And it's never just greater, just equal to, it's always greater than or equal to, right?
Equal to.
And that's for the updates that might happen.
Yes, or things get removed sometimes too. So sometimes it'll just be less than or equal to. We'll have the last version that the feature we needed was in. They removed it. So equal to is probably the best option, because then you know exactly which version to be. But you want to keep track of all those things, and that's what that stuff is about. Which version? Okay. So now on to back to some Python stuff, and then we'll get to Django stuff at the end. I wanted to show that separately because we're not going to, in our class examples, we're not going to install it from requirements, and probably not going to use a virtual environment either. I'm just going to install it, stick it right on the machine. The virtual environment is just a good idea. We've seen how to grade them, and they're always a good idea. Just create a new one for every project, and then you have a blank slate. So then your terminal, you can run the line pip freeze and see everything that is not part of the default installation. And if you do that in a virtual environment specific for your project, copy and paste that list to the manifest, and you're good to go. That's one of the biggest advantages of using virtual things, but we've seen that, so we probably won't see it very often in class here. So I'm going to create a new Python script here in Spider to do some stuff. That looks small on my screen now. As in, is that readable? Everybody see that okay?
Yes.
I can't scroll in on the output side. I can scroll in on the text side. So everybody's seen some, I guess we should start with loops, right? Counter controlled loops. That's our basic. Okay. I is going to start at 0, while I is less than, say, 12. We'll print the next number is I. And then we want to remember to do I increment I before we get to the end. That way we do eventually hit a loop. Everything there look familiar? Yeah, sorry, the basic syntax should have been covered. And then the thing I like to point out every time we have keyword, something unique to our situation, a colon, and then we indent all the stuff that goes with it. That's what I think is just the basic Python syntax. We see that over and over again. You all know what all of that's going to do. What does it say? Yeah, that works. Whoops. Oh, run. And we get to print out the numbers 0 through 12. We can do the same thing with a for loop. For I in, and you probably saw it done like this, range, say 12. The range feature is pretty new. That's only been around for a couple years. For loops are actually something different, but that was added in. We can do it. What we're going to look at in a few minutes, generators. That's what the range function generally took the place of. So I'm going to basically replace the range function. Range was written in C++, so it's really, really fast. So it speeds it up. Generators are kind of slow. We pass a whole lot of work onto the Python interpreter when we do a generator, and basically demand all the RAM. It's like, okay, CPU, give us every bit of RAM that you can while we do this. So that was the traditional way to do it, or we could get to that situation. It's resource heavy and kind of slow. So range function was actually something written in C family, so it's really, really fast. And we just asked for it in Python, but it's still fairly new. Yeah, I'll do the same thing. Print, a formatted string and say the next number is whatever that I is for index or something. Maybe print a couple line breaks in between. Our print statement includes a line break. So if you just need some extra lines in your console, you just put in the print command with no arguments, and that'll give you a line break at least. Just space things out. So probably no surprises there. Anything in our variable explorer? We only kept one variable.
Oh, okay. You said if I do a print with nothing in the parentheses, it'll skip a line.
Ah,
Ah,
automatically includes a line feed,
thank you.
which can be useful. Notice we only have one of those I's. If I check the variable explorer, if I put a breakpoint in here and use the blue run button so that it stops at some point. So there's the I from the first one. It's already counted up to 1, and zoom buttons are in the way. I have to move those. So then if I start stepping through instructions, oh, I was expecting it to show the temporary I in the variable thing. Notice we still don't get that inner I statement. There's that not run that. Then it pauses, so run the next line, next line. Okay, so it just used that one that was already there. It didn't create that. One of the nice things about Python is we get really good memory management. And I wanted to use this to introduce a picture that I'm going to draw quite a bit on the board. Those who have had me before, I know you've seen the pictures. Has everybody seen a stack heap diagram?
Yes. And I missed the chalk. I missed the chalkboard, by the way.
Yeah, I'm indifferent about the board, but I really just like markers. I like my chalk at home, but if it's in my home gym, if it was any room other than the home gym, it's a bit dusty, but dust doesn't hurt the weight set. So this is, for those who haven't had me in class before, if you've had me in class, you've seen me draw lots of these. This is a stack heap diagram. So stack is one of our data structures, so it's heaps. They fall in the same category as lists. We're only going to look at lists and generators tonight. Stacks and heaps are two of the most popular ones. A stack is what the machine does most naturally. And a heap is the best way for a machine to do it. We have to force the machine to do it, but it's by far the best way to do the machine to do it. We'll talk about those when we get to data structure, when we talk about data structures in detail. But in general, our code, the code we write, what we think about with the text file, everybody's aware that what's in that text file is not what goes to the CPU, right? It goes through several layers of interpreters and translators before it finally makes it to the ones and zeros that pass through the CPU. Oh, we're going to look at functions tonight. We'll be able to look at disassembler. I guess we can go ahead and disassemble it and see, at least look at the assembly language version of our Python. But we can think of our code that way. It starts reading things in, and a stack is like we would think of a stack of plates. After we wash dishes, finish dinner, go wash dishes, start putting plates away, the last plate that we put on that stack is going to be the first one we grab the next time we're ready for a meal. Right? So it's last in, first out. Heaps are a more complicated data structure, but that's what we usually use for RAM. So this picture represents our code and what's going on in the RAM chip. So when we store a variable, we have a name for it here, and that is referencing some value over in over in the RAM chip. I is what? So A is 97. And B, C, D, E, F, G, H, I, 110. all right, 110. So 110 in binary code is what's being stored over there. But we have that a bunch of ones and zeros making up that data. And different things can happen with it. So when we ran through our first loop, we gave something that name. The computer set aside a spot in memory for it, which Python is terribly inefficient for that. So really, when Python set aside a spot in memory, it would have given us 50 times more than we needed and eventually dropped that off whenever it got around to looking at it. So we go through that code, and then we finish with one of them. And then we get to that inner one, and that reference is good again. So it's going to break that first reference and point to the same data, which then itself has another pointer in it. I'm going to step ahead because I pointed at the 110 a second ago, but we go 0, 1, 2, 3, 4, and just work all the way up to 12. But eventually we'd have a 12 in here. 1, 1, 0, 0. And then we get to that second loop. It's like, oh, this variable has the same name. Doesn't look like we need this right now. So let's just store 12 somewhere off to the side. And set this back to 0 for that inner loop. And when we're done, we bring that other one back in. Really, really good memory management in Python. I wanted to start introducing the picture stack heap diagram. So the stack represents our code and the heap represents what's happening in RAM. If you haven't seen those pictures before, there are a couple of lectures this semester where I draw those a lot. You can draw a couple of them tonight. Actually, I'll probably just erase what's on there and come back to that a couple times tonight. Seemed like a good place to introduce that picture we're going to use quite a bit. So the range function is kind of new. I'm going to jump ahead a little bit because the next thing to talk about is list, but everybody has seen a list, right? Or oftentimes we'll say array, because array does not show up in everyday language. Array has very strict requirements, and we do not have arrays in Python. There's a data structure very similar to arrays that are called lists. Arrays have a rigid algorithm, so it's based off an algorithm, a recursive algorithm. So maybe we have our start bit, and the next element is the start bit plus 3 times the size of our data, plus a few extra bits for padding. And then we just keep running through that algorithm to find the start bit for the next little chunk of data every time. Thing is, it's also has to be similar type data, but Python is an open type language. So it automatically fails the definition because we can't have similar types of data. Or we're not restricted to similar types of data. A list just contains a lot of pointers. Might as well use that picture for that. I'm going to introduce a list, and then I'll come back to that. So a list, on the other hand, so let's say we have 1 byte integers, the one everybody learns about in the SDEV 120 class, right? That's not actually what an integer is stored. If you're in C++, you can do uint _8, and that's the one you learned about in the SDEV 120 class, that most basic version. Uint _16 is how you would handle the Unicode values. Otherwise, there's extra layers of complexity to make them to apply some usefulness that we already know is going to be there, but would make it way, way harder in an introduction class. If we had a bunch of, say, 8-bit data for an array, maybe we do something like start plus 3 times size plus 20. So we have this array, and arrays need specific types. So I'll say uint underscore 8-bit integers. So we know all of our data is 8 bits, and the computer is going to pick some starting point. It's going to pick maybe a bit. I'm just going to make one up. 27,234 as the starting point. Someplace in our RAM chip. And then each one is 8 bits long. So we have that starting point. 3 times 8 is 24 plus 44. So this number plus 44, well, it's just a 7 in one spot. So somewhere else in the RAM chip, that bit 27,277, we start our second element. And then that little discrepancy that some of y'all have probably noticed, this is where our data starts. And this is where our data ends. When we ask for it, we have to ask for the beginning. That's why our indexes typically start at 0, because it's the start point plus 0. But when we get to the end, right, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 bits. So the start point plus 8 bits, or one data point, is where the next one would start, is also where this one ends. So there's that discrepancy between the indexing and the counting. Comes from that. We ask for the beginning, which is the start point plus 0 elements, because we haven't moved from that start. But when we count it, that's the first element. We don't actually have it until we get all 8 of those bits in. So there's like fancy algorithms like that, and we are restricted to type. So we do not have arrays in Python. Another one that's much easier to work with, and when we get to data structures, we'll make one to see it's really, really easy. A list isn't something super fancy, complicated. It's really, really, really easy to make a list, which the one built into Python is nice, has pretty much every feature we might need, right? But how often do we need every feature built in there? That's a lot of overhead. And Python's our slowest language, so if we need to buy some time back, it would be nice to not have that overhead. Lists are really, really easy to make, so we could make one that perfectly fits our need and doesn't have anything beyond our needs, and buy back some of that speed we lose with that general list that has to have every feature people might need when they use a list. So we'll make a list whenever we get to data structures. That's going to be one of the first things we look at. So when we have a list, what a list is our first element against the start point plus 0. So we index at 0, but we just add a little bit of extra data on there that points at the next data point. And then we'll add a little bit of extra data on the end that points to the next data point after that. And eventually we have our last element in our list just points at nothing. There's not another thing to point at. Electrically, it just goes, that electricity just goes back to ground and we don't do anything with it. That's how we know when we're done with it.
Difference between doing the list and the array, because like on the array, you said that if it goes from, if there's 8 bits, it's going to start at 0 and then go to 8 plus 0. And then so the next one, it's continuous. The next one would start at 9 and go on. So with this one, it looks like they're all separate lists and then it points to the next one.
Each one starts over every time.
Okay, so it's not going to be continued like on the array.
Yeah, the array has that math. I wrote out a math formula. So the array uses that math formula to decide where the next one is. This one is completely dynamic and is fully dynamic. So if we wanted to get rid of, say, this element in an array, we have to recalculate that entire structure. We delete this, then everything afterwards has to move back a spot. And we
Like
do
a table?
not really like a table internally.
Okay.
But there's a lot going on with an array. We don't have arrays in Python, so we don't need to worry about that here.
Good.
A list, it just has a pointer to this next one. So if we wanted to get rid of that, all we have to do is stop pointing at it. We just stop pointing at it and point up at this one instead. And that's no longer in there. Garbage collection is going to grab that the next time it notices that there's data that we have no way to access.
I guess I said table because I was thinking like for the DBS, whatever, database stuff management. So in this case right there, you said we have to rewrite it because that's dependent. If we don't rewrite it and we take one out, it's not going to know. We have to rewrite it so that it can go to the next one.
Just this little piece at the end, just the pointer.
Okay, just that little piece.
Point to something else. So when we make this, that's a data field we put in our object that says next.
Okay,
Change the value of next.
and where it goes. Okay.
We change what's assigned to that variable. So that's the structure of a list. It's fully dynamic. We can get rid of things. We can add something in. So, okay, I need another data one here. Need another data point. We could add that in there and then point back at that previous one. Everything's fully dynamic on it. So lists usually have advantages. Typically, we'll still say array when we're talking about them because list also has preconceived notions with humans. We use list all the time, right? Grocery list, to-do list, and none of them mean this. So we have those preconceived notions. And the reason I was hesitant on saying table there, yes, sir, table there, Tiff, is when we talk about these things in detail, when we get to data structures, we are going to see some stuff in a table. And the stuff that gets tabulated is very different. We'll see that in a couple weeks.
Okay.
But that's what a list is. We're just we're pointing at the next one. So really, we have data scattered everywhere, and what we access are these little pointers here. I can erase this one. So like this is pointer 0, pointer 1, pointer 2, pointer 3, and pointer 4 just heads to ground. There's nothing at the end of that one. This will be important later when we get to data structures. That's why I'm taking the time to talk about it now. And I know you all know how to type a list already. You would have seen that. We only have about 5 more minutes of content before the break, so stretch it out a little. And there's a big difference here in how lists are handled as opposed to everything else in Python. If I do another stack heap diagram over here. Nice thing about this class is I know y'all have already seen functions in the previous class, right? So I can refer to a function and you'll know what I'm talking about. Or we have our main, which we'll talk about this evening, guard statement if you haven't seen that before. Maybe we have this variable called x there. That points to the number 3. And then we have this other function on our stack that we're going to call that needs that x passed in. How do we get the x from this part of the stack up to this part of the stack? And there's 3 ways we can do it. In Python, we do not take control of that. It's already controlled for us. So we can either pass by value, by reference, or by pointer. We won't code pointers into our Python code. We will see a pointer this evening, but it was built into the language from the beginning. So we'll ask for some pointers, but we won't use that. That's pointing at a direct spot in memory. So that's like passing the address. Pointer or pass the address. So, do I have a number written up there? Whatever number I wrote up there earlier, we're going to pass and say, use the data at bit 27,300 and
Okay.
whatever number I'd done. That gets complicated. So we won't really use that in Python. So our options are passed by reference or passed by value, and those show nicely in this picture. So this arrow here is the reference, and the data is the value. So whenever it comes up to the function, there's a spot for it to go, and passed by value, we make a copy of the original value. When passed by reference, I need a color, it's gonna get hard to see there.
And what does that say above main on the stack?
FUNC,
Okay.
abbreviated function, whatever our function is called. Passed by reference, instead of creating a new arrow there, we would grab this arrow. We're going to refer to the thing that points at that data. So Python has really great memory management. Has terrible memory usage, but great memory management. So there's a garbage collection that goes through every few milliseconds and cleans things up and reorganizes it. And to build that really great memory management, not memory usage. Memory usage is awful in Python. It's one of the worst, one of the reasons it's so slow. But luckily there's a manager that automatically cleans it up and reorganizes it constantly for us to optimize it as good as it can be, or as sloppy as our usage is. So if we say if we have data, what kind of data do we have? Do we have an entire novel stored in a string, or do we have the number 3? The computer doesn't know how much to set aside, so it's it has to just set aside a whole bunch of space and adjust it later. Everything in Python is set to pass by value. Whenever we pass, we're always passing by value in Python. I'll draw a circle around that. All right, Python always passes by value, except for one situation. If you look over at this picture, all we really have are references, those arrows. So a list has to be passed by reference, because by the nature of what a list is, it is only a bunch of references. But in general, we'll pass by value. And kind of introduce those pictures so you'll see how I'm using them before we get to the data structures one, because there it's important to visualize what's going on, because the goal there is to optimize things. But that's a couple weeks away. Hopefully that makes sense. In general, as far as coding goes, if we want to write a list, I'll call it my list. We use square brackets and then comma separate the values that go inside of it. 3, 14, 87, 2, 9, 5. I'm just going to put some random ones in there. That's probably good for there. I need to add some white space. I don't like typing at the bottom of a screen, so that's just some arbitrary white space to keep the cursor someplace nice. And y'all have seen this. If we need to do some stuff, so print my list. If we need to access something from it, we use square brackets and the index number. So maybe index number 1, which would be our second element, divided by my list index number 0, 1, 2, 3, 4, 4, 5. That'll work. That's in there. So we get the result of that, and we can refer to each one in particular. Or the reason I went ahead and jumped ahead and started talking about lists is because this is what for loops are actually for. What we call a for loop in Python is what we call a for each loop in most of our other languages. So we'd say like for item in my list. And then it's going to go through those one at a time and refer to them, give it its own name. Then we don't need the indexing. I'll just print them out for our example here. You all have seen this before, right? Print out item. Save that, give it a run. Whoops. Okay, don't save it because I haven't saved it yet. And then it just prints them out one at a time. So we don't necessarily need the indexes to get to the list. That's what for loops were designed in Python were designed to be. Counter controlled loops, they intended to do it this way. So what we call a basic for loop in, say, the C family is actually an abbreviation of this sort of while loop, where we set up a counter, set up a condition, then increment or decrement our counter on the way through. It's an abbreviation for that, but we usually also have a for each loop and say for each item in the list. There's different syntax in every language, and that's what the for loop in Python was intended to be. And it'll try to split it up to whatever is natural for that. So for list, it's each element. For stacks, it's going to be each element because those look a lot like lists. For heaps, it's going to be nodes because those are a special type of tree. For a file, it's going to try to split it up on the lines, unless we're in a CSV file, at which point it makes sense to split it on the delimiter. But wherever the most natural place to split that collection of data is, usually we want to work in a collection, and that's where the advantage comes in. The analogy I always use of why we want to use this, again, a lot of times in classroom examples, a list isn't going to be any easier than it would be for a variable. But when we're done in the classroom and move into the world at large, we'll see much larger data sets. When I took a class on R, the data set we used was all the cholesterol data. They removed identifying information, so took out people's names, and there was date of birth, date of death if applicable. So it wasn't just the people that are alive, there's also all the people that have passed away. That they had height and weight and all the stuff needed to calculate BMI, along with the HDL and LDL levels. That was a huge data set. Massive, massive, hundreds and hundreds of millions, right? There's 300 million Americans alive. Other Americans millions of Americans have passed away that did have their cholesterol level recorded and added to that. What is the National Health Institute? Can't remember, HLA, or no, that's not it. HL something. I don't know what the acronym stands for, so I always have trouble remembering that. It's much easier when it's like WHO, World Health Organization. But I don't know what the acronym for the American health data collection is. But it seems odd to me. I'm sure I could Google it, but either way, lots and lots and lots of data, big data sets, then that becomes more useful because when we have 500 million data points, it's a little awkward to put that index number in and keep track of that. We do have an assignment on data analytics later, so you'll see that when we get to module 7. In the classroom, it doesn't really, it's hard to visualize the usefulness of it. So I have an analogy I like to go over. Let me grab a couple things. I don't have any textbooks. So for a typical school day, you're probably going to grab a few things, right? Randomly grab some stuff from my backpack to do the example. So it's like, all right, so heading off for a typical school day, you're gonna need some things, so like a notebook, a laptop, a folder, another folder, and a notebook, a calculator, handles some stuff, a pen, pencils, and we got a bunch of stuff that we're gonna need throughout the day. So that's not bad. We can carry this around, but there is a better way, right? Usually when I do this analogy, I have enough stuff to drop, but I didn't have any textbooks or anything. I think y'all are all well aware that there is a better way to carry that than just as a pile in my hand. Got the backpack here, so I can just take this stuff, throw it in the backpack, and then whenever, okay, I cannot hold on to this pin for nothing. There we go. Now the pin's in the backpack too. It's all unzipped, but can carry it around quite easily that way. And then there's a process when we get to class, right? Get into class, like, okay, here's where I'm going with the stuff that I brought for the day. And what do I need? Maybe it's a math class. Like, okay, I need a calculator. So we start going through the backpack. Is this a calculator? No. Take the next thing. Is this a calculator? No. Keep going. If this is a calculator, it'll set it out, leave it out. Yeah, that'll work. Take that out. Some other stuff I might need for a math class, like I need a pen. Okay, start going through here. Is this a pen? Nope. If this is a pen, I'll leave it sitting out. Oh, that look like a pen. If this is a pen, I'll leave it out. Yeah, that'll work. And that's the process, right? It goes much, much quicker because we're an intelligent species, so we don't have to spell it out every single detail. We can do multiple ones at a time, but a computer can only do one at a time. And that's the process for carrying it. So our collections of data are like that. It's like a backpack. We put all our data in a backpack to keep it organized. And whenever we need something from it, we're just going to loop through everything in the backpack and check a simple condition to see if that's the thing we need or not. I like to use that analogy because sometimes in classes, in the classroom setting, because we're so restricted on time, things have to be small, and it's hard to see the advantage we get out of working with collections. And for loops are kind of set up more for those. But we can take that a step further to a list comprehension. What if I needed a list of all the numbers up to 100 divisible by 3? Somebody want to tell me how we would put that together?
Make a range of 0 to 100, and then I guess just divide it by 3, but I don't know how to make it into a list.
Yeah, I was thinking modulus 3, which, yeah, the remainder, if we divide by 3, if that's equal to 0, no remainder, then that means it's divisible by 3. So make it into a list, like what you said there, that was the next thing I was going to look at. We could add it to a list, right? Triples starts with a blank list for I in range of 100. If I mod 3 is equal to 0, if we divide by 3 and there's no remainder, then that means it goes in evenly. Then we can add it to the list. Triples dot append adds a single item, just because I don't have any place to talk about it in the plan for this evening's quick pass at syntax didn't include it. Extend, if we had a list, if we had 2 lists and wanted to put them together, we would extend our first list with the second list. Or we could append one item at a time. Append I onto that list. And that would give us that list. If I run this, we should see that. I'm gonna give that a name, so I stop doing that. What is this? Loops and list .py. Give it a nice little name there. So we can see in the list, there's all the numbers divisible by 3. 0, 3, 6, 9, all of those nicely evenly divisible, but it took several lines. There is a way we can do that more concisely, and that's what's known as a comprehension. I put y'all on the spot there, but y'all, everything in there probably looks familiar from the previous class. Comprehension, we can do that all in once. We know we want a list, so I'll give it I'll just call it P, is assigned an empty list, and I'm going to do some stuff here inside of there. Well, I'll give it a name, 3s, that way I can use T in here. Let's say P, and I can put that for loop right in here. So everything above, I can put inside those square brackets when I initialize the list. So instead of the comma separated value, I want to put this logic into that initialize the list thing. So T for T in range of 100. Syntax we know, right? But just in a different situation. And then we can add in the filter. If T mod 3 is equal to 0. So the same logic we just saw, but all in that initializing the list. That's something that shows up quite a bit. And see over here, we end up, if we look at the variable explorer, we end up with the same list. Oh, for those in the room, the Zoom pictures are in the way. I should get those out of the way. The middle might be a good point to put them, because I was going to keep looking. But you see, we got the same list, but it's a lot more concise in the code. And that's called a list comprehension. I guess I should spell that out explicitly because I'm getting ready to do something else. Does that all make sense? And notice the pattern, the variable, possibly multiple variables, right? T, X, and I, we're going to do something, then we need more, then we need comma X, comma I in our for loop, and probably comma X, comma I, or and a bunch of ands and ors over in our filter. But we have those three parts. So the variable we're looking for, the stuff we're looking for, where we're looking for it. So here, just in the range up to 100. Extremely useful for files. If we have like a big file and we know it's in the file, dig through that file and don't bother reading in the whole file, just only bring in the ones that are needed. And then a filter to make sure it's only the one we needed. So instead of reading in the file, we can put our file handler here, loop through that file handler and filter down to just the data we need in that list in one line. Let me copy this for something. Some of y'all haven't had me before, so might not talk about keyboard shortcuts. If you didn't know, before the mouse and dragging around to highlight, we would hold the shift key and use the arrows. It's a really useful way to highlight stuff. So to copy this line, so what I'll do is click somewhere on it, and every keyboard has a different home and end key. The control function in, yeah. So on my Mac here, function right arrow goes to the end of the line, and function left arrow goes to the beginning of the line. And I'm going to indent this just to show you if I hit function right arrow again, or the home key, which is on a different place on every keyboard. It toggles back and forth between there. So if you need to highlight a whole line, which by this point, y'all probably well aware it happens a lot. A really good quick way to get there is if your cursor is anywhere in there, hit end, and then hold shift and hit home. Oh. Shift and home and highlight that line. And I always go to the end first, because if there's an indent, which there will be in Python code, the home key just toggles back and forth across that indent. And then we can copy that and get rid of that indent so it doesn't crash on us. go back to the end, come down a couple of lines. Oops. I'm on a Mac, so Command V, not Control V. Tricks. Need another name because I want to do it the same thing. What do you think is going to happen if I put parentheses there instead of square brackets? Zoom in. So the first one had square brackets, the list comprehension, and the second one has parentheses for the same code. We're going to run it. It didn't crash. Again, the Zoom thumbnails out of the way for the people in the classroom. It didn't crash, so it's not a problem. It's not an error. We don't have the data though.
Is tuples mutable?
So it's different than a tuple. Yes, I probably should have mentioned that. Sometimes we don't want to change our data. Once we set it there, we don't want to change. So if you initialize the list like this, we also have something called a tuple, which is exactly like a list, only we can't change.
And the tuple has parentheses, right?
Yes.
Instead of the brackets or the.
When we do this thing, so variable, loop through, looking at some spot, and then filter, it gives us something different than a tuple. We can see over here, it says generator object. It doesn't store the data. Square brackets stored the data. A generator is a temporary list. So instead of storing that somewhere, what I'm going to do is say for I in that. And then print I.
Sheesh.
Does it make sense what it does now? It's a temporary one because we can see over here, as I printed them out, we had it, the same list, 0, 3, 6, 9, 12. But it's kind of what you're probably used to the range function doing. Actually, before the range function, that's how we would create the range function. We would just set up some sort of selection that would go all the way through stuff. That's called a generator comprehension. So comprehension is kind of the same thing. We filter down to a short list, and the difference between them is a list comprehension keeps it around. Whereas a generator comprehension uses it and discards it. Which hopefully you can see the usefulness in that immediately. Because a lot of times we would create that list just to loop through it once. If we're only going to loop through it once, there's no need to keep it around wasting our RAM. Other things can use that RAM. Our program's probably not the only one running on a computer, right? If you opened, I'm on the Mac, so it looks a little different, but if you're on Windows, you open Task Manager, look at all the running programs, there's way more than just one Python script running at any given time. There's other stuff that can use that RAM. We're going to see parallel processing and multi-threading near the end of the semester. We could use that RAM for something else. So there's no need to keep things around a lot of times. So it creates a better way to create a list, and either a permanent one for list comprehension or a temporary one for a generator comprehension. And the generator actually comes out of a special type of function that we'll look at after a break. Does anybody have any questions about that? You're definitely going to practice some comprehensions, especially like if you use the OS module, so you have can get to the directories and tell what's a folder, what's a file, dig through your whole subsystem on your computer, dig through all of that and put it right into a list so you can start doing stuff with it. I'll leave that for you all to practice, but now is probably a good time for a break. Oh, did I overlook something in the chat room? Oh, okay. Yes, those are Those are really, really useful. You want to use them quite a bit. It's probably a good time for a break. 10 minutes sound good to everybody? I see big head nods here in the classroom. So my laptop says 7:18, so we'll get back to it at 7:28.